Testing 1, 2, 3. One, two, test. All right. I'm gonna work on this problem first, and then maybe do a hard. Let me change the scene. All right, so this is a problem. Longest substring without repeating characters. So let's read this problem first. All right, let's see. So given a string S, find the length of the longest substring without duplicate characters. And they give you some examples here. Second, there was like a video playing of my stream on my phone. Anyways, so giving a string, find the length of the longest substring without duplicate characters. An example, ABC, ABC, BB. The answer is ABC. So it could be BCA and cab in here. So basically, we just need a string that doesn't have any duplicates. That's why the answer is 3 here, because A, B, C are all unique, and then it starts to repeat, so it cannot be 4 or 5. Here it's all duplicates, so the string can only be of length 1. Let me copy paste this into my Neovim. So usually when they want a unique strength, a unique length of different characters, that's a pattern you need to know. It's sliding window. So what you can do is use a left pointer. So we'll have a left pointer, and we'll also have a right pointer. And what we're going to be doing is expanding the string using the L index and R index. So let's call it, well, for now, let's just call it L and R. So for example, A, B are both unique, so we just keep expanding right pointer and comparing the strings from index 0, right? So here, index would be 2, so the length would be 3, right? Then when we go to the right again, you see there's a duplicate. So what we have to do is bring L to the point where there's no duplicate. So we always have a unique string. One way to do this is to have a set and kind of check. Let's say we have a set and we start from index 0. So in the set, since we see A, right, we can add A, and then when we move to the next character, we'll have B, then we'll have C. And then once we move right again and check that there's A in the set, what we can do is keep moving the left pointer until we get rid of that character. So for example, L is at 0 right now. So we keep moving it. We move it. And then they'll know, okay, there's no more A. So the R then at the right index will add this A and continue moving. Right, then we hit the B again, and we'll have to do that again. But instead of the set, what we can actually do is have a hash map and track the character's index. So for example, if you start this over again, so we'll have a hash map. And so at this point, character A will be at index 0. Then we move to the right. B will be at index 1. We move again. C will be at index 2. Now, once we move again, what we can do is the following. We can, instead of going through until we remove the A, we can just kind of compare what is the best, where's the best place to move L if there's a duplicate, right? So either we need to move it forward by 1, where A is here, right? So we have 2 choices. Move it by 1, so left index will be at the B, or maybe L is already somewhere beyond A, but right, but we tracked A before. So then we either move L by 1, or what we can do is just keep it in that same place. Because then we know that L is already beyond that. Maybe there was a duplicate before and it got moved. So let's implement that. Let's see if it works. So we set up a hash map. And then we'll need the left index. And we'll start the right index. We'll start the right index also at 0. And we'll go through the whole S. Right. So current value will be whatever at wherever our index is at right now. So what we need to do is now we need to check the current values in the hash map. Now, if it is, we'll just do something. But for now, let's say if it's not, we'll just update the index of the value, but we don't have the index right now. So what we need to do is actually enumerate right index, because we need index and the value. Oh, actually we do have the index. Sorry, what am I talking about? Right index. Okay, this is just a placeholder for now. We'll fill out the logic in a second. Okay, so we'll update the hash map current value. So for example, A, and we'll place the right index where it is right now. And then we need to check for the longest string length that we found so far. So we'll start with 0. So max length when left index and right index at 0 is going to be 0, right? And how do we update it? Well, the way we update it is we can check what is the max length, or whatever the difference between the right index and the left index right now. So do that, and we need +1, right? Because, for example, let's say left index is at A and the right index is at C. 0, 1, 2, right? So 2 minus 0 will be 2, but we have 3 characters we need to include. So +1. So at the end, we'll just return max length. So now, but what if we do have the value in the hash map? Well, like I mentioned before, what we can do is either grab that value and move it by 1, or maybe left is already beyond the duplicate. So let's try that. Let's see. So left index will be max of either, maybe it's already beyond that duplicate, or is the tricky logic for this one. I'm trying to think of a case where that would happen. I mean, the if you get stuck like on parts like this, the easiest way would be to implement it just using a set, or just keep moving the left index until the duplicate value disappears from the set. So either left index or right index +1, I think. Might be wrong for the test right now. Yeah, that is incorrect. Let me just do it, because I cannot think of the example right now of the case this would happen. Well, let's trace this example. So the longest length here will be 3. I'm guessing it will be WKE. So we start left index here, start right index here. Let's see if I have something in the chat. And then so the first current value will be P. It's not in the hash map yet, so we'll send it to 0. So hash map P, the index is 0, and then test for length. So the max length will be 1. And we go here, we add W. then W is 1. Once again, we check for right index minus left index plus 1 and max of that. So now we have 2 variables. Now this is where we hit the duplicate, okay? So at this point, if the current value is in the hash map, what we need to do is check. So the left index is at 0 right now, right? So we want the max of 0 or right index plus 1. Yeah, then it will skip. What if it's left index plus 1 or right index? That would be still duplicate. All right, let me do it with the set. Yeah, see, sometimes you can get stuck on something simple like this, but like instead of overcomplicating it, let me just do the set. So here what we can do is instead we can check if the value are set. So then if it is, we need to keep removing the keep moving the left index until we remove that value. So we can do this char set. What's the remove? Yeah. So char set remove whatever is at left index right now. So whatever is at left index, we remove it, and then that will kind of loop through until that character is gone. And once that character is gone, oh, we need to also increase the pointer left index because we want to keep moving to the right. So now, once that character is gone, we need to add that character. Insert, there's that. I haven't done Python in a while. So let's see, we want to add the current character at right index. Oh, there we go. Let's see. So let's run it, submit it. Boom. Not bad. Yeah, so sometimes, you know, when you try to be fancy and add certain type of more optimized tricks, you can also get stuck. But there's always different ways to do something. So it's still going to be the same runtime because this while loop only will run. It's not gonna. It's only gonna be moving forward. So this is still gonna be on time and on space, I believe, because we're using a set. Yeah, because this will only run on time. Yep. So that's it for this problem. Kind of did this more for as a test stream. I got like a new setup with the different scenes. As you can see, I can change the scenes. Boom. But yeah, if you come up with a different solution that's optimal as well, go ahead and send me a message or leave a comment. All right, that's it for today. I gotta go actually do some work for my actual work, but I'll continue lead coding later.